Alright guys, so this is going to be our second day of word problems. You have 5 formulas that you're going to do. Yesterday you did 2 together, the exponential growth and decay. This is your third, it's half-life. You might have heard of half-life in your science classes. Half-life is the time required for a quantity to reduce to half of its initial value. The time required for a quantity to reduce to half of its initial value. So for example, if the half-life of something is 10 years, right? Let's say you start off with, I'll give you an example quick. Let's say you start off with, we'll say 100 grams of a radioactive substance. And then 10 years go by. Now you only have 50 grams. 10 years go by. Now you have 25 grams. 10 years go by. Now you have 12.5 grams. So this has been 1, 2, 3 half-lives, or 30 years in this example. Okay, the formula for half-life, some similar variables. We just have h that's being introduced. A equals p times 1/2 raised to the t divided by h. So remember, if you're going to type this into your calculator, you have to put parentheses around that. A is the end amount. A is the end amount. P is the starting amount, just like before. A is what you're ending with, or your future amount. P is your starting amount. T is time. And H is the half-life. So the reason why, if you remember the formula from what we did the other day, the reason why there's no R, right? R was the rate, is because this is actually an example of exponential decay. Right? Exponential decay is 1 minus r. Our rate for half-life is 50%, which is 0.5. So 1 minus 0.5 is a half. Okay, so that's why there's no 1 minus r in this formula. But anyway, so this is how I'm going to want you to apply these questions as well. Kind of like what we were doing the other day. I want you to read the question. I want you to write what you're looking for, write down the formula, and then plug things in. Get rid of the word problem as quickly as you can. Okay, so for number 1, the half-life of some whatever. So you start reading, you see half-life, so we're going to write down the half-life formula. A equals P times 1/2 raised to the T divided by H. If you wanted to write 0.5 instead of 1/2, you can also do that. So the actual question, I'm sorry. So the half-life of some radioactive element is 36 years, and its initial mass is 10 grams. Algebraically determine how many grams of the substance remain after 60 years. So you are solving how many grams of the substance remains. So you have to think, is that going to be the end amount, the starting amount, the time, or the half-life? How many grams? That's not a form of time, so it's not T or H. So it's between A and P. Is it how much it's ending with or how much it's starting with? If you read the question, it says it's starting with its initial mass, right? That's what initial means, is 10 grams. So you are solving for A here. So P is 10 grams. That's how much you're starting with. T, the time, and H. So this is where it gets a little confusing because T and H are both a form of time, but H is specifically the half-life. So it says that the half-life is 36 years, and T is 60 years. T and H, they don't have to be in years, but it has to be the same unit. Okay, so if it says that the half-life is hours, then the time should be talking about hours. Not a big deal though, don't panic about that. So when we plug this in, we have A equals P is 10 times 1/2 raised to the T is 60 divided by 36. So for this question, you do not need to use logarithms because the variable is over here. The variable is not in an exponent. So you are just going to plug the entire right side into your calculator to get an answer. So when you plug this in, you get 3.14 something, something, something. It rounds to be 3.150, right? This says rounded to the nearest thousandth. That's 3 decimals, 150 grams. And that's your answer. Okay? So again, that one was a little bit easier because you didn't have to use any logs for that. But let's look at the second one. Element X is a radioactive isotope such that every 22 years its mass decreases by half. So its mass decreases by half. This is literally talking about the half-life. So 22 years is the half-life here. H. If an initial sample of the element is 1,500 grams, algebraically determine how long it would take. How long it would take is a form of time, right? So it's either time or half-life. We already know the half-life. For the sample to decrease to 500 grams. So again, the question, algebraically determine how long it would take. That means that you are solving for T. You're not solving for H. It doesn't ask you to solve for the half-life. It will specifically say half-life. So we're solving for T. So we need an A, we need a P, and we need an H. We already said that H is 22 years. A and P are talking about the size of it. So we either have 500 grams or 1,500 grams. So remember, we're supposed to be going down in size. If we're going down, that means that the starting amount should be more than the ending amount. Okay, so that's one hint that you can use. Or you can read it as an initial sample is 1,500 grams. So you can think initial is your starting amount. And we want it to turn into eventually the 500. So now this is where we get a little tricky because this is our formula, right? A equals P times 1/2 raised to the time divided by H, both as your exponent. So now our equation is 500 equals 1,500 times 1/2 raised to the time is what we're solving for, divided by H is 22. So the variable is up in the exponent, right? The T is an exponent, so you have to use logs. So what you're going to do first, you're going to divide the 1,500, just like we were doing all week. Divide by 1,500. This will cancel out. 500 divided by 1,500 is 0.3 repeating. Remember, you're going to write out 5 decimals equals 1/2 raised to the time divided by 22. Now, once you get the base and the exponent isolated, you take the log of both sides. So log of 0.3 repeating equals the exponent, time divided by 22, can go in front of the log of 1/2. The exponent goes in front of the log. It just looks, it's not just x anymore. It's t over 22. It's the same rule. It just looks a little bit more confusing. Divide both sides by the log of 1/2. This will cancel. So you're going to do the log of all of those decimals divided by the log of 1/2. In the calculator, that should give you 1.58496 equals t divided by 22. We've solved equations like this a whole bunch of times. If I do this, then you always know what to do, right? You're going to cross multiply. Always, always, always cross multiply when you get to this step. So 1 times t is t equals, and then you would do that number that's in your calculator right now times the 22, and that's going to be your answer. We are rounding to the nearest hundredth, so 2 decimal places, and we get 34.87, and we're talking about years. That's your answer. Okay? All right, one more. So we've solved for A, we've solved for T, and this last one I'm going to show you how you would solve for H. A radioactive substance has a mass of 350 grams at 8 a.m. and 240 grams at 2 p.m. Algebra can determine the half-life of the radioactive substance. So again, it's specifically asking you for the half-life like I told you it would. So we're solving for H. Again, do this little setup, that way it gets rid of the word problem. If we're solving for H, again, this is our formula. If we're solving for H, that means I have to plug something in for everything else. Solve for H, so A is something, P has to be something, and T, you have to plug in a number. You have to plug in a number for all three of them. So has a mass of 350 at 8 a.m. and 240 at 2 p.m. So it starts off at 350 grams, and eventually it goes to 240 grams. The 8 a.m. to 2 p.m. thing is just meant to throw you off. Remember, from P to A, right, your T value is how much time has passed to get until it gets to that A amount. So from 8 a.m. until 2 p.m., that is 6 hours. So T is going to be 6, okay? So we just plug all of this in, and then it gets rid of the word problem. So 240 equals 350 times 1/2 raised to the T is 6 divided by H, okay? So I'm going to zoom in on this now because nothing else matters. My first step, just like before, we divide both sides by this P value. 240 divided by 350 is 0.68571 equals 1/2 raised to the 6 divided by H. The exponent is where your variable is, right? Variables in the exponent, so we need to use logs. So we have the log of 0.68571 equals, the exponent comes out front, 6 divided by H, log of 1/2. Divide both sides by the log of 1/2. The parentheses around that don't matter really, so don't get worked up over that. Divide by the log of 1/2. On the left side, when I do that in the calculator, I get 0.54432 equals 6 divided by H. Same thing as before. It looks confusing until I do this, and then you all know to cross multiply. So 1 times 6 is 6 equals 0.54432 H. To solve for H, you divide by that 0.54432 number. So this will cancel. I get H by itself equals, remember you're doing 6 divided by 0.54432, blah, blah, blah. Do not do the opposite. Okay, we're rounding to the nearest hundredth of an hour, right, because the time was hours, so half-life is hours. And we get 11.02 hours. Okay? So again, submit these notes. Get the worksheet done tomorrow. Let me know if you have any questions. This stuff is hard, but you need to know it for Algebra 2. They glance over this really quick, but it's a big, big topic for the Algebra 2 region. So that's why I want you guys to do well with this, okay? All right, let me know if you have any questions. Have a good day.